Okay, so we're looking at mixed exercise 6 from the first year core textbook. So that's focusing on circles. On question 16, it's an exam question and problem solving. It does looks quite challenging, and it's worth 8 marks. So that gives an indication we're not expecting anything particularly straightforward here. Okay, so what do we got? So we've got the equation of a circle. We've got 2 tangents, and we basically want the equation of the lines of each of them. Okay, so let's think about what we know. Well, I mean, I certainly know that I can obviously see that the y-intercept of each of them is 12. Okay, so I know that both of these 2 lines will have that general equation. Okay, so that's going to be helpful, I think. The other thing I know about them is they both just touch the circle. So I'm starting to think discriminant here. Okay, so let's write out the equation of the circle, then I've got everything I need on my notebook. Okay, so equation of the circle, in red so I don't miss it, is x minus 6 all squared plus y minus 5 all squared equals 17. Okay, well, so what would I do if I was trying to find these points of intersection? I would most definitely substitute the straight line into the circle. I wouldn't be trying to rearrange that equation of the circle. So if I do that, I would get x minus 6 all squared plus, and then where it says y, I'm going to substitute in mx plus 12, and then I've got the minus 5 all squared. Okay, so then I've got a quadratic that, well, it's a quadratic in x, but then I've also got, obviously, this m as well, which is basically what I'm trying to find, but I think we're going to be able to figure that out. So what should we do? Well, let's square all those brackets out. So the first set of brackets is going to become x squared minus 12x plus 36. Then the next set of brackets obviously simplifies to mx plus 7. So it's mx plus 7 times mx plus 7. Okay, so that is going to be m squared x squared, and then I'm going to have 7mx twice, so 14mx, and then 7 times 7, and that all equals 17. So if I tidy that up, so there's my x squared terms. So I'm going to take out 1, so I've got 1x squared plus m squared x squared. So I'm going to factorise that. You might be able to see where I'm going with this. Then in terms of my x's, I've got minus 12x plus 14mx. So again, I am going to, rather than write them as sort of 2 separate terms, I'm just going to take out the 14m and the minus 12. So I've just got that single x term. And then the constant is nice and easy. I've got 36 plus 49, and then I'll minus the 17. Okay. So normally I'd be trying to solve that, but obviously I can't solve it if I don't know what n is. But if I go back to the situation they described, I can clearly see, well, I know if they're tangents, they are just touching the circle. So this quadratic equation here should only have one solution, because there's only one point where they cross. So one solution, or a repeated root, makes me think of the discriminant. Okay, so you can see why they said this was a problem-solving question. So that quadratic should only have one solution, which means discriminant equals 0. So this was why I wanted to factorise those terms, because now I can clearly see the coefficient of x squared, the coefficient of b, and my constant. So b squared minus 4 times a times c should equal 0, so at least it's not an inequality one, I suppose. Small mercies. Okay, so I'm going to square out those brackets. So I've got 14m times 14m, so 196m squared. I've got minus 12m times 14m, and I'll have that twice, so that would be minus 336m, and then I've got 12 times 12. Then I've got minus 4 times 68 times 1. So that's giving me minus 272. And then also minus 4 times 68 times m squared. Yep, so that is just... Oh, we need to get the highlighter and getting the pen. Right, so that... Yeah, it's just what I got when I multiplied that out. This whole bit here is squaring out those brackets. So if you needed to write that down as separate working, then absolutely. And then the minus, done that again, haven't I? Right. Then just for completeness, let's just clarify where that comes from. So that is the minus 4 times the 1 times the 68. Get rid of all that mess. Okay, and I know that that should equal 0. So what have I got? I've got 196m squared minus 272m squared. So I've got minus 76m squared, and then I've got minus 336m, 144 minus 272, I've got minus 128. That is absolutely going to cancel, but I'm not going to bother. I'm just going to, well, I'm going to multiply through by minus 1 just to have less negatives, but then I'm just going to go straight to the quadratic solve mode in my calculator. So A is 76, B is 336, C is 128, and I am getting M is either minus 8 over 19 or minus 4. Okay, now that's looking relatively hopeful because I can see they should both have negative gradients. So feeling relatively confident. You see there was a lot of number work there, so lots of potential to make a mistake. So we'll check our answers. But so don't forget we already had the plus 12. So now I've got my two values of M. Those would be the equations of those two lines, yeah? So again, as far as I can judge, that seems okay. Obviously, we used the fact that the intercept was plus 12 right from the start. They've both got negative gradients. I really hold my breath and hope. Oh, thank goodness for that. Yeah, we got both of them. Actually, I'll tell you one other thing I could have done is said which was which. Oh, goodness me, what am I doing? I came back to that, otherwise I would have left that right. I've got M on the brain. That was not right at all. That's what that should be. Okay, but yeah, so what I was going to say is the other thing I can say which is which, because obviously line 1 is the steeper one in the negative direction. So I could have said that's line 1, and therefore that one's line 2. Okay, just double check I haven't done anything else, staff. No, we're good.